Okay. Manuel, you're on stage now.
Way!
Okay. As I already mentioned in the opening session, Manuel tried to do some sports last week and that didn't work out as he planned to. So he needs to deliver his talk basically remotely, but I think we fixed all the technical issues now. Yeah, thanks, Manuel, again, that you at least deliver remotely. And yeah, I would say it's your stage.
All right, thank you very much. With this being said, I'll take over the share. There we go. All right. So, now I need to figure Zoom. Here we go. So, all right. Hey, everybody. Thanks for not being on site. I saw on the latest post on LinkedIn and it looked just awesome. So I'm really sad I couldn't make it. But as Nico said, I'm playing handball, or at least I'm trying to play handball from time to time. And this time, yeah, I kind of borked my knee for a bit. So walking and everything else related is a little hard right now. Hence, I'm doing it remotely. Nevertheless, my name is Manuel. I'm working for a German consultancy company called Concentric. I used to work previously to rejoining Concentric. I used to work pretty close within the CNCF startup ecosystem. I worked at Traffic Labs beforehand. I'm officially still a traffic maintainer. Nevertheless, I really didn't touch any code in the last 2 years or something, so I'm not sure I should actually still be it, but okay. I'm also a so-called Dapr meteor. So like I really love the project. I really believe in them. Hence, I'm doing this talk today. And yeah, then there was some service mesh stuff and whatever, but it's really not that fun. So we're talking about Dapr today and how it helps with durable workflows in terms of the cloud native development ecosystem. So there's a couple of key points I want to touch on with you. So first, the challenges of distributed systems, then what is actually Dapr, but just super quick, because I think that most of you have heard it by now, but in case you haven't, just to get you all up to speed. Then we touch on both of the main key advantages in this scenario here for Dapr. One is Dapr in different environments, and two is durable workflows and styles. Then just some benefits and lessons learned, and hopefully a demo if everything is going smoothly for this one. So if we look at today's distributed applications, they more or less look like that, right? We have some front-end applications, we have some gateways, we have a bunch of like microservices sitting in between, or better, they sit behind. They all have different capabilities. Some need to have like some persistent storage, some needs to talk to message brokers and whatnot, right? And this is just like how distributed applications, now typically, and if they are not a modular, are built today. However, while this is great for like scalability and all these things, there's a couple of challenges that developers typically start to face when they work on landscapes like that. One is, for example, how do I orchestrate business logic across services? Because if we take this e-commerce example, if I have a checkout, right? Like I purchased some stuff out of the store. I usually want to have like notifications. I want to get like an email notification, or I get a notification because like Amazon, like I get it in an app or whatnot, right? So there's like business logic that needs to be orchestrated across different services. And at the same time, what do I do if I have like transient errors, right? Like maybe, I don't know, my message broker is down, or I'm overload on capacity or whatever. Like there's a bazillion things that could theoretically go wrong, and that makes me, or that forces me to handle those errors like gracefully and like make sure that my entire system still is reliable and still is able to do things. And with all this, there's a couple of things we can do to help on that. First, as I already told you, let's quickly look at Dapr. Dapr in itself is a graduated CNCF project. I think for about 1.5 years by now. I think they graduated. It's half a year. Maybe they graduated at like last US KubeCon. But anyways, beforehand, Dapr was sometimes like Dapr stands for Distributed Application Runtime, and I think that's actually pretty fitting. I don't call Dapr a framework. Some people like to call it a framework. I think it's not. I do know why they call it like that, because it's really framework closely, and we will see that in code throughout the demo. But I really think it's more of a runtime rather than a demo. Why is it a great runtime, and why does it help application developers? Well, because it brings a lot of capabilities just out of the start, basically. Dapr in itself runs with a lot of different languages. There are a couple ones mentioned on screen, and it is able to do so because it's really language agnostic. It basically just exposes some HTTP APIs to your application, and then your application can make use of the building blocks that Dapr offers. For the sake of this talk, we are especially looking at the workflow building block, but there is a couple more. Like there is publish subscribe, there's servicification, there's state management, there's actors, there's jobs for some sort of batch and whatnot. And like there's a bazillion things. It helps you to integrate in your platform, in your application, so you don't have to build everything from scratch anymore. And the good part about that it's really portable. Like it doesn't matter if you run it in like on your local Kubernetes, your local Docker, in Azure, in AWS, in wherever, bare metal VMs. Like it really doesn't matter at that point in time, and we will see why. Dapr in itself, it is so portable, not only, but also because it uses a sidecar pattern. That means that each and every application that you run inside whatever your environment is, and you kind of like enable it to be Daprized, depending on the environment, someone, or you will have to do it by yourself, will need to spawn a sidecar next to your application. And this sidecar is where all the magic happens, right? Like if the shopping carts wants to do things, for example, if the shopping carts wants to do things like service invocation or secrets or whatnot, the app talks to the sidecar, and the sidecar does all this stuff. Like the app would talk to Dapr would send out publish subscribe, for example, and then another app, which is also Daprized, would get the event, forward the event to the application, and case closed. The cool part about this is that this makes it all like supportable and so you can do it in all the different environments. So if we look at local development, for example, you could read secrets from a local file, or you could do pub/sub with a Redis, right? And then put it to like the other applications. While if we were running in the Kubernetes, for example, you could read the secrets from a HashiCorp Vault and use RabbitMQ as the pub/sub engine, for example. And all of this is like transparent to the application, since the application just includes the Dapr sidecar and basically just tells Dapr send message, Dapr read secret, right? It really doesn't matter, and it doesn't even know where it reads the secrets from or what it used to develop to send over the message, because it's just transparent, and we will see that in code throughout the demo as well. So was touched on Dapr in itself. We do know now what it does and what it's for. Let's go into like, why is this so great in combination with durable execution? What is durable execution in itself? Durable execution basically guarantees you that the code that you intend to run does run to completion, even if if shit hits the fan in between, right? It's a concept that's kind of like it's a concept that means that you persist the state of like the execution flow of this specific task, basically, to a state store, and that whatever happens, you can catch up, right? You can make sure your code runs to end. So you are guaranteed that whatever you have programmed in terms of business logic really will be executed end to end. And this allows you, obviously, to like handle errors gracefully and all that stuff. But why is this so cool, and why does it link to Dapr? Well, typically, and you have seen the building block earlier on, durable execution can be used or is used by workflow systems. Workflow systems have been around for like ages, right? And they are used to automate business processes. some older systems or known systems in this would be, for example, Camunda, or like if we are in the AI stage, as we all are, you could think about NNN or whatever, right? But like that's the key of it. And if we look at workflow systems, they are basically built on 3 pillars. One is like an authoring environment to create the workflow, which, for example, in Camunda or even in NNN could be like the bubbles that you move in between and you draw the connecting lines and all of this. An engine which actually executes and runs the workflow, right? Because one needs to like orchestrate and schedule all the stuff that happens. And a state store, as we said, for the durable execution, that persists the workflow state, so the system knows like where it is inside a given execution of a workflow. And as already told, Dapr includes this building block Dapr workflow. And the workflow API does exactly that. It enables the developer to do durable execution of potentially long-running business processes super easy and like super seamlessly, because it's like this one building block out of the application. It's like one API it calls, and then he can do like full durable execution within your application. The cool part about this is that you author the workflows in code, like whatever code, like in whatever language you want to write it. For my demo, I did it in Python, but you can do it in whatever, basically. And this building block, this workflow building block, also has support or allows you to do a couple of patterns that we will look at, like chaining, fan out, and all of this, which you will use, given your use case, right, to optimize for whatever you need to do. So how does the workflow engine work? Well, you have your workflow app. It hosts in code all the workflow and activity definitions. Workflow is like the upper workflow, and each and every workflow consists of multiple activities, right? So that's how you build it together. And this workflow app schedules workflows activities throughout Dapr. So it does like a call, basically an API call, a post to the Dapr sidecar, which in this scenario is the Dapr workflow engine, right? And it does stuff to the state store, it reads from it, it writes to it, everything, and it only returns the result of the given activity or the given workflow to the app back. So in terms of Dapr, or in terms of the application, it calls Dapr just to like, hey, there's the workflow business process started. And that's like it in terms of what you need to do for scheduling inside your application. The workflow engine in itself in Dapr is built on top of a different building block in Dapr, which is called Dapr Actors. Dapr Actors is like, it, as the name suggests, it reacts on stuff that is done within the whole Dapr thing. So it's reusing some of the other Dapr key components to realize this workflow engine, such as state store, for example, or even the actors, so that you can run the code. How we do it is that a client schedules a new workflow instance, right? Like this is our workflow app, and it does have this particular workflow. It has a start and an end, and it has 3 activities in between. And the client just starts this particular workflow, right? And the workflow engine will always store in the state store which activity has already passed, so or when it already succeeded. So if you need to replay it because the process crashed midterms or whatever, it's always able to catch up because it always knows where it comes from and what it needs to do. So this workflow engine allows to starting a workflow, getting the workflow instant state. It allows you to pause the workflow, to resume a workflow, to terminate a workflow, or to purge it because it's done, case closed, whatever, right? So you have like the full power of scheduling and managing the workflow inside your application. So if we want to look at the workflow at an example workflow, right? There could be a message, like you could receive some sort of webhook or whatever that starts the workflow. Then there could be an activity to get like a secret or invoke an API or whatever, right? This could be one activity. Then we could wait for a user to allow something, or I don't know, it could be a wait, then you would have some sort of fan out, because maybe they can like two things run in parallels, right? Like store some results, invoke another API, whatever. And then there could be like a closing activity, for example, to publish a results email, and then it's the end. So with this in mind, right, with this hypothetical workflow, we can look at the patterns that we can do. One we already saw, we can do task chaining. So we can just put multiple activities as much as we like in order, and they are executed in succession. So we would typically use this if the order of things that we need to do is like important, because they really need to run in this given order. And the cool part about is since we reuse state, right? We are talking still about durable execution. Each and every activity can use the output from the previously run activity for its own activity, right? So we can build up on the steps and everything, and that makes it pretty smooth. The next pattern, and we saw it in the example already, is fan out, fan in. So if we can execute stuff simultaneously, we can start panning out, because maybe there is stuff that can be done in parallel, right? And they're independent of each other. And if all of those are done, we've kind of pan in back into our next state, right? And there we can even aggregate the results of the different activities and stuff. So the next activities after the fan-in would know what has happened, and so we can like speed up things if the process we need to model allows for it. I think I skipped one. Yes, sorry. Then we can use the monitor pattern, and we saw it in the waiting for external event, right? So we would execute a recurring activity, for example, each 10 seconds or whatever, and then we could periodically check for a given state and only continue if the state has been reached, and otherwise we wait. We can use the external system interaction, right? We saw that in the dummy flow as well. So we could wait for an event to happen, basically. Like if we think of an internal order process, like, I don't know, you guys need a new MacBook, you order it inside your company, someone needs to approve it. We could like model this, wait for the improvement as well. And then last but not least, workflows can call other workflows. And that's pretty cool, because then you have like parent workflows and child workflows. And this allows to really do complex workflows, since you can like compose it out of smaller reusable workflows, right? So if your application gets bigger and bigger, this will be the possibility to potentially like reuse code and all of this, so it all doesn't get so super messy. Why would I do this? Well, you have a unified developer experience, like the same logic runs literally everywhere without code changes, since it's also portable, right? Since Dapr abstracts stuff away, and we will see this in the demo, which I'm going to do now, you only care about your business logic and not like about all the implementation details, such as which store and whatnot. And since workflows are code, they also allow, for example, for versioning. So like you can revert workflows, you can check on which version a particular workflow was executed and all of this. So you can really just focus on your logic, and that's it. So with all this done and said, it's demo time. So there, I saw that I forgot to open this, but that's super fine. Let's quickly go full screen on this one so that we can see things. So what do we have? We have, maybe I should show you the application first. We have this application, right? It's a simple dummy application just to order burgers and beer. Doesn't really matter at that point in time. And as you can see, I already tested it for a fair bit. So you can order burgers, you can order beers. Maybe it's a little early for beers today, but that's okay. Let's say a cheeseburger and an IPA, doesn't really matter. And we just call it CNS Munich, doesn't really matter. And I click on place order. So what we will see now is that currently the drink is being poured, right? Like because we ordered drinks and burgers, we see that stuff is pouring. While we wait for it, I can show you back in the code what actually happens now. Go full screen. We have this order service in this app, right? And all the app does is we can see that there is activities. So there is an activity for cook burgers, or there's an activity for pour beers, right? So this is really, like I said before, this is what it eventually comes down to, right? We have workflows and activities, and we annotate a given code block as an activity, and to like make it reusable and everything. We will also have an activity to complete an order. We will like when both things are done, like the beers are poured and the burgers are cooked, then we will complete the given order, and we have a workflow which stands out because the kitchen can like cook a burger while the bar is pouring the beer, but they don't need to they don't need to wait for each other. They can do it at the same time. And so we have this workflow where we do things. Then there's just some bare bone just for like API and all of this doesn't really matter. The important part is that if we look into a given activity, let's use the cook burgers activity for here, for this example. It's basically a simple Python function at that point in time. We just annotate it. And then for all the Dapr related stuff, all we need to do is, well, we do get a Dapr client, right? Since we are in the context of the order service, so this is like the front end. All the front end needs to do is we want to also invoke the kitchen service on the method name cook. We give it some data, right? Because it's basically an API call. This is a post, and then it just thinks. So the order service really doesn't need to know anything about what's going up in the kitchen service and the cook. In particular, it only needs to know that we use this method, right? And then it just does it. So, and this is basically the same for each and every service. So if we check the kitchen service, in the kitchen service, it only gets this API call on the cook route, and then it just thinks. Obviously, since it's dummy, it doesn't really do a lot. Rather than just wait for a random amount of seconds and return that it's potentially cooked the burger. So that's pretty cool. I'm a little confused that it still shows pouring. That probably means that my demo broke, because otherwise it should have shown that. But nevertheless, what we can do, yeah, something is wrong here. Fuck me. Is my environment still live? Yes, it is. So, okay, no problem. What I wanted to show you as well is, because I talked about portability, you have this component, and this is basically how the things get get movable, because you define what you need to do in YAML inside your configuration, right? So for this scenario, this is a PubSub component, and it does know it because like you configure it, right? Like you say PubSub, type PubSub Redis. So this is a PubSub component, and it uses Redis as the event store, and the Redis to use is here. And for state, it's the same. It's state, and hence like state.redis. There's the address of the Redis instance, and off we go. So you could change this to your liking, to match your environment, to whatever, right? It really wouldn't matter at that point in time. I'm just wondering why my application is not doing what I wanted. This is really weird. Maybe we quickly look in the order service. Yeah, there is a problem with my environment. Okay, no. Since we have 2 more minutes, let me quickly see if the reboot does fix it. Maybe it does not. Who knows? That looks kind of broken. I feel my local cluster died. Yeah, that looks, maybe this got ready. How about you? Watching Trust Anchor? That's not so bad, actually. Let's quickly restart the service as well. Okay, one quick try. And otherwise, uh, otherwise, uh, uh, just things. So hopefully not fully up yet. No, all right, it doesn't want to do it. But the key takeaway, for whatever reason, I don't know where this failed. Sorry, guys. It did work before. I don't know. I don't know what's the issue right now. Um, so with all of this, um, like we have activities and code, we just define them, right? We can version with it, all of this. Since we are in the age of AI, you could also use this as like the bare bone for writing your agents, right? Because you have the state store, like it does everything, right? So you could use this to like do durable workflow agents, right? Because like it always keeps the context if you want to. It has all the state. You can apply the same pattern. You can pen in, pen out. So hence the Dapr folks did like a separate project, Dapr agents, which kind of is like the path to what you could do next. Um, if you're really curious about that, I don't know who of you visited KubeCon in Europe, but there was a great talk from Fabian from Zeiss about how they use Dapr workflows in production to orchestrate like a lot of their business logic. So check it out in case you're interested. And otherwise, thanks for going to a remote talk. Those